Hi, this is 7-5 proportions in triangles. This is where we will look at triangles and we will pull out special proportions within them based on given information. Here in Theorem 7-4, it's called the side splitter theorem. And you can see that we are given a triangle with one side parallel to a side within that triangle. So in this case, we have segment RS is parallel to segment XY. So therefore, on either side of those parallel lines, XR is to QR as QS is to SY. So just as an example, if this is 1 to 2, and this side is a length of 4, QS would have to have a length of 8. All right, because 1 is to 2 as 4 is to 8. Ignore the fact that that might not look reasonable with this particular drawing, but just understand that that's how we're going to set up our proportions. In problem 1, we're going to use that side splitter theorem with variables to set up a proportion and then probably derive an algebraic equation to solve for x here. It's very important that we are given that these two lines are in fact parallel to each other. Without being given that information, we're not allowed to use the side splitter theorem. So if I started off with x plus 1, that has to match up with km. So x plus 1 is to 12 as x is to 9. And now we're going to cross multiply here. When we cross multiply that 9 by x plus 1, you'll see the distributive property crop up there, and then we'll multiply the other way. 12 times x is just 12x. So when we distribute the 9, we'll be left with 9x plus 9 equals 12x. I want to move the x's to one side, so I will move it to where it'll remain positive. This cancels, so divide by 3, and x equals 3 then.